It's a teaching method based on the National Mathematics Curriculum used for kindergarten through 6th grade in Singapore. And students will solve mathematical problems in an abstract way by using numbers and symbols. It also teaches students the how and why of foundational math while building their skills up, and the goal of prepping them for more advancing topics. And this approach is known for its focus on depth and concepts over memorization and drill, which is typically what we may see in a classroom today. One of the defining features of Singapore Math is visualization. The progression through concrete, pictorial, and abstract phrases and understanding math concepts supports real-world application of math. So the students start with hands-on activities and work through representations and then arrive at their numbers. So it's a constant progression, like up a ladder to get the answer that they need. Singapore Math is about drawing connections, supporting the thinking process, and instilling comprehensive understanding. It encourages perseverance and naturally gives students confidence as they become equipped to solve problems using many different tools. So I'll give you guys a second to fill them out. I had never heard of this before until I started researching it, and I thought it was really interesting. I was watching a video that you guys will see in a minute, and I thought it actually makes sense because some of the maths that I've seen before, I'm like, I have no idea how you guys got this concept as it is already. But I thought this was actually a pretty good way of using a different math style in the classroom.
Technically, Common Core is based off of Singapore Math. I don't know if you're headed there. I'm sorry if I
No, you're good. Yeah, I have that in the PowerPoint.
Oh, okay. Yeah. I just saw pros and cons next, so I just assumed.
No, you're good. Yeah, it's in there.
Okay.
So here is the video. It's just a short video. It gives it gives an example of how Singapore Math works.
Today we're taking a look at Singapore Math. It's a 7 steps.
Here, I believe. I'm sorry.
12 treats. How many did they have altogether? These types of problems can be especially sticky, but if we use our 7 steps from Singapore Math, it can guide us through it easily. First, we're going to determine the variables, the who and the what. In this case, we've got 2 different who's, Micah and Caitlin, but they're thinking about the same what, Halloween treats. So we're going to write treats next to each person's name. Next, we're going to draw the unit bars, and they always start off equal. Even though Micah and Caitlin are 2 different kids, and we're talking about 2 different amounts of Halloween treats, our unit bars are always going to start off equal. Next, we're going to chunk the word problem and adjust the unit bars to match. Micah had 4 more Halloween treats than Caitlin. The first thing I did was add 4 more bars onto Micah's original unit bar. This will show that he has the same amount as Caitlin has, but has 4 more than that. If Caitlin had 12 treats, how many did they have altogether? Next, I chunked Caitlin's unit bar into 12 pieces for her 12 treats. I also did the same for Micah's. Because he has the same amount, that 12 that Caitlin has, he also just has 4 more. And again, we always want to make our unit bars look the same. We always just want to add on to them, depending on the information. Let's place our question mark. We're going to use that same teacher squiggle and put a question mark at the end to show that we're adding those 2 amounts together. Here comes the computation. 16 for 16 treats that Micah has, plus 12 to show Caitlin's treat amount, equals 28. And everyday math and Singapore Math both like to use quick addition strategies. So here I took the 10 from 16 and added the 10 from the 12 together to get 20. Then I added the 6 and the 2 together. Just a faster way to add. Let's write a grammatically correct answer sentence. Micah and Caitlin had 28 treats altogether. Sounds and looks good to me. I hope this has given you an idea.
So that is an example of a Singapore Math problem, and I really like this video that I found because as you can see, this is a word problem, and typically my hardest thing to solve in math classes were word problems where you have numbers and words and people and places all coming together, and I thought this was a really good visual representation of how to solve that kind of problem. So this may be a little hard to see, but this is just like a visual component of what their mathematical framework is. So it all starts with problem solving, and then it reaches out to attitudes, skills, concepts, processes, and metacognition. So it gives some definitions like what metacognition is, but the attitudes are like their beliefs and interests, perseverance, confidence, and appreciation, like I mentioned in the first slide about building up their confidence and their math skills. And their skills themselves are numerical calculations, algebraic manipulation, more things like that that they'll work on with this method. And then the concepts, they're numerical, algebraic, geometrical, those kind of things. And then the process is like reasoning and communication and connection with all these problems. So I thought this was interesting. I know it wasn't actually part of a slide that we were supposed to have. But it was created in 1981, and the one thing I really wanted to point out are the revisions. I found there were quite a few revisions in Singapore math. There was one in 1992, 1999, and then 2001. And 2001 is where we left off, and we're still using that today. So I thought that was really interesting. And so this is like kind of a pacing guide, just like a day-to-day pacing guide, as to what would happen in a week. So you would see on day 1, they're starting with topic A, continuing that into day 2, introducing topic B, added practice, et cetera, so on throughout the week. So that just gives you like a glimpse into how a week of Singapore math would go. And then this is a lesson plan example. So you can see they have the teacher, the grade level, and the data. And then they have the Common Core standards addressed in this lesson, the chapter and page numbers, which that lesson ties into. And then the delivery strategy I thought was really interesting. You have concrete, pictorial, or abstract, so you check off which one you're using for that day. And then you have whole class, independent practice, and cooperative learning groups, objectives, and activities. And then was today's lesson differentiated? I thought that one was really interesting. You check yes or no, which we don't have on our lesson plans. I really like that one. And then you have student grouping, student working with teacher, and then student working at a station. So that is what their lesson plan template looks like. And then I added all these words over here, which is kind of what Singapore math encompasses, and words that describe that math style. So some pros versus cons. Singapore students are the world's math leaders. It has been proven that they lead the world in math, so apparently they're doing something right. They focus on mastery, not just learning for a test, like I mentioned with drill and memorization. Visual and audible learners are thriving, as you can see from that video that it had. It shows how those students can benefit from this. The layered strategies build upon one another. It aligns with Common Core standards, and studies show instant improvement. On the other hand, there are cons, and it requires continuous teacher training and learning. So as Singapore math progresses, the teachers also have to go back and learn how to do that. And a con, it also aligns with Common Core standards. So what your opinion is on Common Core, it can either be a pro or a con for Singapore math. And then materials are used for every class period, every day, for every school year, and the cost of these materials add up because it is such a hands-on visual learning. And this method may not work well for students who move frequently. Like if a student moves in to an area where they teach Singapore math, they don't have an understanding of what it is already. Whereas on the other hand, if a student has always been around Singapore math, but they move out of a region that teaches that way, they're going to be lost because they're either going to have no idea of what it is or have no idea of any other kind of math style. And then there's less of a focus on applied mathematics and more so on that of ideological approaches.
Alright, so moving on to traditional math. This is probably the type of math that you all are most familiar with. It's the most predominant approach to math education in the U.S. from the early 20th century to the mid-20th century. It focuses more on procedural knowledge rather than conceptual knowledge. It's also a very teacher-centered approach that uses direct instruction. So because of that, you can probably tell that it's derived from a perennialist/idealist philosophy. Methods and topics include addition, subtraction, multiplication, division, long division, arithmetic with fractions, lowest common denominator, arithmetic mean, volume, carrying, and multiplication tables. And some curriculum examples that you might be familiar with are Saxon Math, teaching textbooks, and family math. So this is just a quick example of how in traditional math they would go about solving a basic multiplication problem.
math expert. Today, we're going to go over the traditional way to multiply. So, I'm going to work through a couple examples with you. Hi, my name is Suba Agarwal and I'm a math expert. And today, we're going to go over the traditional way to multiply. So, I'm going to work through a couple examples with you so you can help learn the rules. Now say we had some number, 64 times 6. With traditional multiplication, all you have to do is multiply each individual number and you carry over what's left. So 6 times 4 is 24. When I say carry over, I mean we write the 2 up here. And then we multiply these. 6 times 6 is 36. We just have this 2 hanging out, so we add that in. 36 plus 2 is 38. Write that down here, 384. So that's pretty simple. But if we have something that has multiple digits, like, oh, what if it's 64 times 12? Like now these are 2 times 2, what do you do? Well, it's pretty simple. Do the same thing we did initially with the 2. So 2 times 4 is 8. 2 times 6 is 12. And then when we go to multiply this number, you just put a 0 in here. Just put in 1 0, and then you multiply. 1 times 4